Some SN1 reactions, order of reactivity of alkyl halides towards SN1 reactions. So that is like this. Tertiary alkyl halides, they are more favorable towards secondary alkyl halides than primary alkyl halides or methyl halides. Okay. So this is the order of priority towards the SN1 reactions. And one more thing is allylic and benzylic compounds. They are also more favorable towards the SN1 reactions. Allylic compounds and benzylic compounds. Next, coming to substitution nucleophilic bimolecular reactions. Substitution nucleophilic bimolecular reactions. Okay, these are also called as SN2 reactions. Okay, substitution nucleophilic bimolecular reactions, which are SN2 reactions, and these are also called as second order reactions. Molecularity is 2 and order is 2. Why? Because rate of the reaction, that is equal to concentration of alkyl halide and concentration of nucleophile. So in SN2 reactions, rate of the reaction depends upon concentration of alkyl halide and also concentration of nucleophile. Okay, so that's why its order is 2 and molecularity is also 2. So that's why this type of reactions are called as SN2 reactions. Then coming to alkyl halides. So here alkyl halides, which are primary alkyl halides, they are more favorable towards SN2 reactions. Primary alkyl halides, okay, more favorable towards the SN2 reactions. For example, methyl chloride is there. Okay, so methyl chloride converts into methyl alcohol. Okay, when it undergoes reaction with H2O. So in H2O, OH minus acts like nucleophile and it attacks carbon atom from the back side. Carbon atom of the methyl chloride from the back side. Back side attacking takes place here in SN2 reactions. And reaction gets completed in a single step. SN2 reaction is a single step reaction. No mechanism is there. Okay. In SN1 reaction, two-step mechanism is there. First one, carbocation formation, and in second step from carbocation we get the final product. Okay. And one is rate determining step, which is closed step, where one molecule involves there. That's why molecularity is 1, order is 1. Whereas in SN2 reactions, here this is a single step reaction. Alkyl halide undergoes reaction with a nucleophile and it forms a transition state. From transition state we get the final product. So this is the single step reaction. Okay. For example, primary alkyl halide, which is methyl chloride is there. Methyl chloride reacts with H2O. Okay. So in H2O, OH minus is nucleophile. So we get CH3OH. Okay, Cl gets substituted with OH. Okay, and along with this HCl. Okay, so this is the reaction. And here, this reaction takes place through the formation of a transition state. Okay, if you write methyl chloride like this. Okay. all the hydrogens towards the left side and chlorine atom towards the right side. And OH minus released from H2O. This is nucleophile. Okay. OH minus is nucleophile. So OH minus plus methyl chloride. Okay. So nucleophile attacks alkyl halide from backside. Backside attacking takes place here. Okay. So from this, first we get transition state. So here first we get a transition state. So transition state here. So this is transition state. And from transition state, finally we get the final product. Okay. So methyl alcohol. So this is the reaction which takes place in SN2 reaction. So first, nucleophile attacks alkyl halide. Here alkyl halide is methyl chloride. Okay. Then from this we get a transition state. So here you see the transition state where OH group and Cl which are linked with carbon, they are indicated with dotted lines. So here dotted lines indicates between carbon and OH group a new bond is formed. Okay. And between carbon and Cl breakage of old bond. Okay. So in transition state we observe two things. One is formation of a new bond between nucleophile and carbon, and breakage of old bond between carbon and already existing group. Okay. Which is called leaving group. So Cl is leaving group, OH is entering group. So new bond formation takes place between OH and carbon, and old bond breakage between carbon and chlorine. So due to this, we get the final product which is methyl alcohol, which having complete inverted configuration than methyl chloride. Okay. So you see in methyl chloride all the hydrogen atoms are at the left side. But here all the hydrogen atoms are at the right side. Okay. So complete inversion takes place in the configuration of the final product. So this type of inversion, this is called as Walden inversion. Okay. So we observe Walden inversion. Okay. We get the final compound with inverted configuration. Okay. And this inversion is called as Walden inversion. So inversion of configuration is observed here. Then coming to reactivity of SN2 reactions towards alkyl halides. So in SN2 reactions, reactivity order. So reactivity order is like this. Primary alkyl halides is greater than secondary alkyl halides, greater than tertiary alkyl halides. So this is the reactivity of SN2 reactions. Primary alkyl halides is greater than secondary alkyl halides is greater than tertiary. Okay.